The big question that we have for Mars is, did life ever exist on that planet? These samples are going to give us that extraordinary evidence.
The Perseverance rover is right now studying different rocks that are on Mars and collecting samples of those rocks and dust to cache those in a sample collection and hopefully have those picked up to bring them back to Earth in the future for further study in all the best labs that we have.
It's quite likely that in some of these potentially habitable environments that we've characterized very well on Mars, there might have been life that existed sometime in the very ancient past. That's the kind of environment that's being explored by Perseverance right now in Jezero Crater.
Jezero Crater is really interesting for this mission because we think it's an ancient lake, and there's this delta that leads into the lake. And that's perfect because if you think of rivers that are on Earth, that's where all of these signs of life get sedimented and stored for really long periods of time. And we're looking for life that we think existed billions of years ago.
And we've in fact got already a treasure trove of materials, of samples that are better than we even imagined we would have at this point. We have a diversity of rock types, including sedimentary rocks, meaning that they were laid down by water, and are fantastic at preserving evidence of ancient life. We've also found and collected igneous rocks, which are actually molten magma that's solidified and can tell us something about the early planetary evolution of Mars. We will be able to learn something about planet formation, planet evolution processes from studying these ancient rocks on Mars that really then we can extrapolate to conditions on the Earth. On planet Earth, there really isn't that preserved rock record. But on Mars, we actually can see that ancient history of that early planetary evolution. How did planets form and evolve in the inner solar system? We will be able to get that from studying ancient Mars rocks.
What we can do with this mission is go broad across the crater floor, delta front, upper fan, and beyond, and then go deep by hopefully getting those samples back and doing every type of analysis you can do. And for astrobiologists, that's the dream. You get the breadth, you get the depth, and you get all the context.
This is going to be a transformative moment for the science community as a whole, because it's going to offer us the opportunity to study these samples for decades to come, to train generations of scientists. When we look out into space, the big question as humans is, are we alone in this universe? Have we always been alone in this universe? And these rocks will have really incredible stories to tell about the history of Mars and the possibility of ancient life on Mars.